All right, let's go over your Unit 2B Day 4 assignment, the practice describing your data. And so this first page had to do with the outliers. And so you wanted to make sure that you followed the outlier rules. And then here you had your computer printout, and there were some things you could ignore, like the number of pieces of data, the trimmed mean, and the standard error of the mean. We don't need those. And then we'll be using that min and max to determine if we have outliers or not and what kind of outliers they are. All right. And of course, you use your Q1 and Q3 so you can get the IQR to be able to get your IQR rule fences. All right. So remember that with our IQR rule fences, we had the Q3 plus 1.5 IQR, and for the upper and lower was Q1 minus 1.5 IQR. So I put in the numbers here. Our fence was 26.375, and then I go and look at this female max, the maximum of the female data. And I can see that the maximum for the female is not above the upper outlier. So in order to be an upper outlier, that maximum has to be above the upper fence, or the minimum has to be below the lower fence. And so we didn't have the maximum above the other upper fence, but the minimum of 2 is below the lower fence. So we do have a lower outlier. All right. Now, the standard deviation rule, that's your mean plus 2 standard deviations, or the mean minus 2 standard deviations. And so there are the fences at 22, and we didn't have then an upper outlier for the females. And then we did have a lower outlier. Again, 2 was a lower outlier. With that rule, the fence was 6.643. So in both cases, what this means is that we have at least one lower outlier. So I did want to mention something that some students had asked during class today. Okay, so here's typically what we're going to have as far as the outlier options. Okay, whenever we're looking at those minimum and maximum. You may have, so one of the options is that you may have no outliers. Okay, so you had no upper outliers or lower outliers. Okay, the other option is you may have at least one, and then this would be an upper or a lower, whichever one it ended up being, outlier. And so what that means is on one side, there was not any outliers, but on the other side, the max or the min, whichever one it was outside of the fence. Well, you only know that one piece of data. So, you could have something where, here's your fence right here, and then you've got, several pieces of data before that maximum right there. Okay. So you could have, in this case, 4 upper outliers. Okay. So you could have more outliers than just that maximum. So we have to say at least one. All right. Now, there is another case. You could say that you have at least 2 outliers. And so in this case, this happens if you know that you have at least at least one lower, and at least one upper. Okay, so if you've got at least one upper and at least one lower, then I have at least 2. I could have more, but I know for sure I've at least got 2. Okay, so these are the phrases that we'll see, and those are happening because of seeing that max and min. All right, so back to this, I'll just let you look at what happened with the male data. There was our fence. We ended up having no upper outliers and no lower outliers on either one of these cases. So you can check your data to see where those fences were and see if you did those correctly. All right, now this was an interesting one. So here we were wondering, based on these two numbers, the 58,750 or the 89,354, which one's mean and which one's median? So I actually pulled a picture from the 2017 NFL salaries just to show you. Look at here. Here is the salary schedule of the players, and you can see that it is skewed right because you have a few way upper outliers. So this skewed right shape gives us the mean being greater than the median, which is, of course, greater than the mode. So, therefore, the 89,354 is the mean, and the 58,001 is the median. Okay. Now, here, if you take this picture and you turn it correctly, so if you turn your head, then you would see, let me see if I can get the writing tool. Then you turn your head sideways and you can see that this is skewed in this direction here. Okay, so here we have this kind of thing. Looking sideways, make sure the number line is going from least to greatest when you turn your head, and then that's how you get that. So the mean is greater than the median. Here, the statement 1 and statement 2 are true, and same statement 3. If the distribution is skewed to right, the mean is greater than the median. So that one is true. All the responses are true. So that's interesting. All the responses are true. So A through D doesn't give all responses true. So this is a weird one in which it says none of the above gives the complete set of true responses because they are all true. All right, next, number 7, statements 1 and 2 are true. 3 is false. 3 is false because histograms will not give you that individual piece of data value. It's a bin of values. Now, I actually did look into the question about dot plots. Dot plots are dot plots are supposed to give you those individual pieces of data values or something like really close. You can tell those pieces of data. All right. Explain why histogram A has a smaller standard deviation than histogram B. Well, simply, histogram A has data more closely clustered around the center, so the average distance from the mean is less. But histogram B has high frequencies, large amounts of data on these outside edges that are farther away from the middle, so that average distance from the mean is greater in histogram B. All right. We talked a lot about today how to do this. We had this 403. So you would split the data, 403 pieces of data to see where is the piece of data that's right in the middle. And the piece of data right in the middle was the 202nd piece of data. So I count up 36 plus 54 is 90 pieces of data. And I go into this bar here, that takes me up to 159 pieces of data. So I haven't gotten to the 202nd piece of data yet. So if I go to 80, whatever that number is, 82, then that takes me past 202. So that's telling me that somewhere in this bar here is the 202nd piece of data, and that 202nd piece of data then is the median. So the median is in this bar from 25 up to 30. Okay? All right. And then we do the same kind of thing with our Q1. We take the bottom of the first half, which the 201 pieces below makes a 101, the Q1. So if I count up 101, that's 90. So the 101 piece of data falls in this bar from 20 up to 25. You can do the other one several ways. You can continue to count up another 101 from the median, or count from the top. Count from the top down 101 pieces of data, and then we can see that puts that Q3 ending up here in this bar from 35 up to 40. Okay? The key on this one that you had to do, now you might have a little bit different numbers than me, okay? But hopefully that still lands the values in the Q1, median, Q3 are still in the same bar. I don't think we were that close to the edges, but you had to first approximate how many pieces of data were in each one of these bars. So I got 4, 27, 45, 50, 38, and 25. So that was what I got, and there was 189 pieces of data. And so therefore, I could find out that the 95th piece of data was the median. That put it here between 16 and 20. The Q1 was between the 47th and the 48th piece of data. And so that put it here in this 11 through 15 bar. And then The Q3 was between the 142nd and 143rd, and that put it in this bar here between 21 and 25. You do the same thing here on this frequency table. So even though you don't have the histogram bars, you still are counting up. I have 17 pieces of data. So the ninth piece of data is the median. So that's 1, 2, plus 5, that's 7. So then somewhere in this section is the median. And then we do the middle of this bottom half and so on. So between the 4th and the 5th, that's 1, 2, and then it's got to be in there is where the Q1 is, and then so on and so forth. And so in the top one, between the 4th and the 5th, puts it in there. Now, this one I estimated the numbers here. I found out in class today, I'm not really sure exactly what's going on. So here's kind of a case for, you can see we have really a poor histogram here. Okay. For one, I don't understand this labeling. Okay. Does this mean that this first bar is data that's in the 40s? Okay. Is that what that means? I don't know. Or are those all 40? Is this a bar that's this number's in the 50s? So I don't really know exactly what that number is. I don't know. So see, this is a poorly labeled, plus it doesn't even tell you the context of what it is. The other thing is there's 28 pieces of data, so that puts the median in between the 14th and the 15th. Well, look at what happens here. 1, 2, 3, 4, 5, 6, 7, 8 plus 6 is 14. So this right here takes you up to 14 pieces of data. So that half is 14 pieces of data. These 3 bars over here are the top 14 pieces of data. So what is the median? I don't know. It's the average of whatever is the top piece here, the 14th piece of data, and the first one down here, the 15th piece of data. So, if these were all 70s and these were all 80s, then it'd be the average of those. So it's not 70, is it 75? I don't know. So again, this is just not very good, well drawn histogram, not labeled well. So that made it kind of difficult. All right. We did talk in class how this is needed to be omitted because we saw that these bins are different ranges. And so that's just not a properly drawn frequency chart. All right. Next, this is an actual AP question. And so here we go. In fact, I think I'm just going to go ahead and stop this video here, and then I'll talk about this one separately to make sure we've got a good job on that one. So let's go ahead and just stop this section right here.